Good morning, this is Mark. Today is Sunday, January 28th, 2024, and this should be called Current Saving Power Supply Part 2. And I have two of these transformers hooked up in series. The primary coils are in series, and the secondaries are wired in parallel, as in this diagram right here. And this diagram here won't work properly because if you wire the secondary coils up in series to make 120 volts, the whole circuit acts like this is one big transformer because the primary and the secondaries are wired in series. So it won't save any current. And this diagram I'll talk about it right now. This is the voltage divider circuit, which is right here. I don't have it hooked up now. But it uses 3 transformers to create 120 volts after, steps it down to 60 volts. And 120 volts goes to the load. But because my transformers are damaged, because I applied 240 volts to them, they're only meant for 120 volts, there's too much copper losses going on. And the circuit only saves about 25% instead of 50%. And the same for these two by themselves. They only save 33% electricity instead of 50%. Due to the copper losses caused by the damage to the wiring. And here I calculated, I'll show you the current measurements when I turn it on. It saves 33.3% using the proportion formula. 0.1 amp comes out of the wall and 0.15 amps goes to the light bulb, which is this. Which is a 60 watt light bulb, but it's burning like a 30 watt light bulb. So for example, if you wanted to get 100 watts, you would have to put a 200 watt light bulb in there to get the 100 watt brightness. Okay, I guess that's all I want to say about that. So I'll plug it in and show you the current measurements. There's the light bulb on, like about a 30 watt brightness. Oh, wait a minute, this is a 25 watt light bulb in here. So that'd be like 12.5 watt brightness. That's pretty dim. So I'm going to measure the current at the light bulb. Going through the light bulb is 0.013. Before I measured 0.015. So it fluctuates a little bit. Okay, we'll say 0.13. And down here, coming out of the wall, I'll have to set this down for a moment. It's measuring 0.11 or 0.10. So that's worse than the last time I plugged it in. I don't know why. Maybe my meter's not accurate. Try it again here. Oh, it's up to 0.14. So it might go to 0.15. So that's even worse than what I calculated before, just before I started this video. But when I order new transformers, 2 or 3 of them, they should work properly, and then I'll have a prototype and I can offer a product, and I can apply for grants to expand my business. And for example, if you want to run a 1500 watt heater, you plug that in to the output, it would give you 750 watts of heat. But of course, you'd have to have larger transformers. Like this one down here is a 500 watt transformer made by Hammond Manufacturing. You would need a couple of those. Okay, I guess that's all I want to talk about this. So thank you very much for watching. Talk to you later.